We're talking about infinite limits and limits at infinity today. So what do those actually mean? Well, they're just fancy terms for stuff we already know how to do, right? So we're looking at limits, which is a calculus thing, but really these are just asymptotes. So we'll start with limits at infinity. If you think of limits at infinity, this means what happens as the limit as x approaches infinity, or as x approaches negative infinity, what's happening to the function. So as we're approaching infinity, getting really, really huge, what's going on in the function? And if you remember, back to pre-calculus, that's basically a horizontal asymptote, right? As x gets really, really, really huge, we're saying, what is y doing? Is y getting really, really huge as well? Is y approaching a certain number, or is y approaching 0? Does it have a horizontal asymptote that y is approaching? So limits at infinity are just horizontal asymptotes. And then infinite limits are really just vertical asymptotes. But infinite limits means what's happening to the function, or what number does the function go to infinity or negative infinity. At what point on this function does the function just take off and go to infinity or negative infinity? And it only does that at asymptotes, right? At vertical asymptotes. So when we're looking for these two types of limits, we're just going to go back to our skills from pre-calculus and remind ourselves how to find vertical asymptotes and horizontal asymptotes. So I'm going to go through this really quick. We're going to do one example of each type, and then we'll come back and do a second video where I go much more in depth. So this is just an overview. So first we have the graph of this function, and we have to decide where it has a hole. Now if you remember, since this factor cancels out this factor, then let's start here. We have discontinuities at 1. We have discontinuities at x equals 1, 2, and 4. Each of those would cause a 0 to be in the denominator, correct? Okay. Since this discontinuity cancels out, it causes a hole, so we have a hole at 1. And then we have vertical asymptotes at 2 and 4. Now we can classify all vertical asymptotes as even or odd. And I know it's so confusing because we use these terms a lot for lots of different things, but now we're talking about, is the vertical asymptote even or odd? An even asymptote means they both go in the same direction. See, they either go all the way up or they both go down. An odd asymptote, they're going to go in opposite directions. So either you have it approaching positive infinity from the right, or you have it approaching positive infinity from the left. And if you remember from pre-calculus that we know whether these are even or odd based on the power of the factor that creates them. So after we've canceled out the holes, we look at the power of the factor. So the factor that created this discontinuity at 2 is x minus 2. And that is raised to the power of 2. So if you remember, that creates an even asymptote. Now this x minus 4 is raised to the power of 3, which means it creates an odd asymptote. So we have an even vertical asymptote at 2 and an odd vertical asymptote at 4. So let's see what this looks like when we're looking at infinite limits. Again, infinite limits are basically just a vertical asymptote. We're saying, hey, at what number does this function go to infinity or negative infinity? And the only time functions go to negative infinity or infinity is at an asymptote. So we're looking at this function. We know that it doesn't have any holes because nothing cancels out. And so we know that it has a vertical asymptote at x equals 2, because that would create a 0 in the denominator. And then once we have this vertical asymptote, it's saying, all right, what's happening as x approaches 2 from the right side? So we're looking from the right side, what's happening? Well, is this vertical asymptote even or odd? Well, the power of this factor is just 1. So this is an odd vertical asymptote, which means it's going to look like one of those two functions up here, right? It's going to look like either like this one or this one. So let's imagine that this is 2 right here. We have to decide, is it going up from the right or is it going down from the right? So to do this with infinite limits, we do something called sign analysis. And basically with sign analysis is we say, okay, we know it's approaching this asymptote and we know it's either going all the way to positive infinity or it's going all the way to negative infinity. We just need to figure out which one. So we analyze the signs of this limit and decide, is this function going to be positive or is the function going to be negative? So on this one, what's going on as x approaches 2 from the right? So we're looking at numbers that are just slightly bigger than 2. So we can pick some numbers that are slightly bigger than 2. Let's pick 2.1. We have 2.1 plus 3 over 2.1 minus 2. So what's going on here? 2.1 or any number bigger than 2 plus 3 is always going to be positive, right? Those are always going to be positive numbers. Okay, and then what's going on the bottom? Well, 2.1 minus 2, that's going to be 0.1, but it's still going to be positive. If this number is bigger than 2, which is what we're looking at, is numbers bigger than 2, is this always going to be positive? Yeah, it's always going to be positive because we're approaching from the right, which are numbers bigger than 2. So this function is always going to be positive as it approaches from the right as well, the bottom part. So if I put in any number bigger than 2, I'm going to get a positive over a positive, which means I'm going to get a positive number, right? So what happens as this gets really, really close to 2? Well, this number just gets to be like close to 5, right? So we get about 5. And then what happens down here? Well, we're dividing by a really, really, really tiny number, right? So we're dividing by 0.1, and then we're dividing by 0.01, and then we're dividing by 0.00001 as we get closer and closer and closer to 2, right? What happens when we divide by a tiny number? It makes a huge number, right? 5 divided by 1 is 5. 5 divided by 0.1 is a bigger number, and then 5 divided by 0.00001 is a huge number. So we're getting to a huge number. And since we've already analyzed the signs, we know that we're getting to a huge positive number. So this is going to be going to positive infinity. And since it's an odd function, we can automatically know that the limit as it approaches from the left, if we needed to know that, which we do right here, would be negative infinity because it's an odd function. We could do sign analysis, and we'll do that in the next video for that one as well. Now let's look at limits at infinity. Remember, these are just horizontal asymptotes, so we're saying as x gets really, really, really huge, what happens to y? So as x gets really big, what are we doing here? Is it going huge, 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 huge? Is it going close to a value, or is it going to 0? Well, if you remember horizontal asymptotes, we have 3 different options that they could be. Either our function can have a top degree greater than the bottom degree, it have the top degree equal to the bottom degree, or it can have the top degree less than the bottom degree. So let's see what happens with each of these. If the top degree is greater than the bottom degree, remember we might have something like x to the 5th plus 3x to the 4th plus, and we don't care about the rest, right, over x cubed plus 2x squared, again, plus, and we don't care about the rest, because remember, when we have a huge, huge number, and we, let me move this up for you. When we have a huge number, we raise it to the 5th power, and then we add all these other huge numbers. These numbers don't matter, right? This is the one that takes over. This is the main one. So if the top degree of our function is bigger than the bottom degree of our function, remember that this one grows so fast that none of this matters, and even it grows so fast that it gets bigger and bigger and bigger and bigger and bigger, and this x to the 3rd on the bottom can't keep up. So basically what we end up with is just no horizontal asymptote, or what we found last year is a slant asymptote, but really there's no horizontal asymptote. As x gets bigger and bigger and bigger and bigger and bigger, it just gets, the y value keeps getting bigger, so it goes to infinity. So for this top degree is greater than the bottom degree, we have no horizontal asymptote, which means as x goes to infinity, y is also going to infinity. So the limit as x approaches infinity of a function would equal infinity or negative infinity. Okay, if the top degree is bigger than the bottom degree, remember that it would be something like, if the top degree is equal to the bottom degree, we have x to the 5th, like 2x to the 5th over x to the 5th. Now what happens? Well, these grow at the same exact rate, so it's almost like these cancel each other out, and we end up with just 2. So if you remember, if the top degree is equal to the bottom degree, then we take the leading coefficient of the top and the leading coefficient of the bottom, and we put them over each other, and that's our horizontal asymptote. So the limit as x approaches infinity of this function would be the leading coefficient of the top over the leading coefficient of the bottom. If I can squeeze that in there. Okay, last but not least, if the top is greater or smaller than the bottom, so we have something like x to the 3rd over x to the 5th. And remember, it doesn't really matter what else is here because all of that stuff doesn't matter. We just care about the biggest term. what's going to happen? Well, the bottom is going to grow way faster than the top. So we're going to be taking a small number and dividing it by a huge number. What happens when we divide a small number by a huge number? Eventually, we're going to get really close to 0. So you're going to have a horizontal asymptote at y equals 0, which means the limit as x approaches infinity of a function like that is going to be 0. So that's the quick rundown. We'll do an in-depth couple of videos for the rest of the examples.